after this presentation from our next guest. Avinash Bhaskaran from Humin Labs is joining us, who also is on our healthware team. Good to see you, Avinash.
Good to see y'all. Yeah, thank you for having me. Really excited to do another one of these great sessions.
Yeah. So what's Humin Lab up to?
So there we go. That's what it's all about. The name's a little misleading because it is really about ed tech and education technology. So is it possible to share my screen?
Yeah, yes. Absolutely.
Good deal.
You just share it and then I'll add it to the stream.
It's because I shared. Yeah, we'll talk about it when.
I've got too many of the same thing open, so I got to make sure I got the right one up. There we go.
Yeah, we know what that's about.
Yeah, we get it.
All right, good deal. So I think the gist of the issue is that there are a lot of really great open source hardware projects that are being used in the applications they're intended for. One of the areas where they could also be applied is for education. STEM, especially in rural areas in the United States and abroad, is wildly underfunded compared to the needs and the kind of emerging technologies that students will be faced with as they grow up and enter the workforce. And the hardware to simulate and provide experiences in those environments is really expensive. We're talking things like NVIDIA GPUs and stuff like that. And the existing platforms like Arduino and Lego also has a lot of these types of things are really useful, but they're highly modular and they're not super applicable to practical scenarios. You don't wear an Arduino. You might wear a wearable device that uses an Arduino, but all those other components, where do you get them from? And how do you put them together? Well, that's where open source comes in, because there are a lot of really great projects that can be adapted to that application. So real quick, I'll just peek into some of these statistics. So teachers and students, hobbyists and makers, and NGOs and universities, these are kind of the big players in the space that we're trying to tackle, which is basically to say there's a lot of really great open source hardware that could solve some of your challenges. So for teachers and students, almost 80% of K through 12 teachers report lacking sufficient affordable STEM supplies. I've kind of experienced this firsthand as I've been networking with rural teachers in the community that I'm in right now, where they're appealing to the state government, the federal government, and local business partners to try and upskill their incoming class of students who are facing a whole different generation of technologies that it was faced by just the grades before them. And so how to keep up with that change in such a place in the world where that kind of change isn't really familiar. 90% of STEM teachers want ready-to-use projects that are mapped to state standards. So this is an interesting application here. And what Humin Labs is really trying to do is there are great open source projects that are built on open source ethos, which is that they're highly modular, they're accessible to use, they're beginner-friendly, they're low in cost, but they may not necessarily be mapped to state standards. So for example, there might be a state standard or an NGSS standard, next gen science standard about machine learning or mathematics. And while there may be great open source tools that do other things, how do you make that same tool apply to, for example, a Raspberry Pi? A Raspberry Pi has to be programmed or configured in such a way that it can actually be used by a student to achieve state standards. And so how do you enable such a device to do that? What's really interesting is, we're not really throwing these kids to the wolves here, because it's shown that project-based learning, especially when they are interacting with new things or a new context, can improve STEM retention by up to 30%. And I've seen this firsthand as I've been working with some of the students in my community using the Open FlexShare microscope, which is an open source science tool. And they really do engage with these types of things, even when they've never seen something that's ever been 3D printed before, or never seen a microscope before. And they really do engage with these types of things. So an obvious application is, we developed something for teachers and students. It's accessible, it's easy. We're adapting open source technology for these applications. Having that kind of infrastructure in place is a great way to onboard people into the open source community. So when they're learning how to make things, how to 3D print things, and excelling in their coursework, this is now a place where elementary school, middle school, high school students can become hobbyists and makers. And existing hobbyists and makers can not only benefit from these tools, but also contribute to them. So kind of really quickly, DIY maker tools are exceeding, 10, 15 billion as a market. And 70% of makers say the open source documentation really determines whether they'll adopt a new technology in this space. 70% also like to prioritize things like reducing waste and extending lifespan, which are critical open source ethos and principles, right? So there are kind of invisible bridges here that Humin Labs is trying to identify and build. The far-reaching goal of something like this would be to populate not only schools and communities in the U.S., but abroad and in places where traditional infrastructure and government are not really catering to those types of needs or capable of setting up a new standard for open source ed tech. So, but it is noted that open hardware can, people know that it reduces cost, and they cite that vendor lock-in is a significant barrier for technological intervention in these places. So it's kind of familiar. It's in the air. Open source can reduce costs, improve accessibility, but the question is still, who's going to do the work of convincing the general public and convincing policymakers that an open source microscope is really just as good as a closed source microscope for achieving state standards and giving exposure. It shouldn't be the best or nothing. There is a middle ground that is actually really desirable for a lot of reasons. So what Humin Labs is all about is we're trying to drive down the cost of STEM with open source hardware. And so the product that we're developing or trying to pitch is a suite of infrastructure tools, services, and resources to help adapt existing and emerging open source hardware to STEM standards. So we're not really making the hardware. We are adapting it, so modifying it to make it easily manufactured at scale and usable by beginners and novices, so that type of thing. So some of the folks in our space, so I didn't make a PowerPoint, but I do have a website. So it's kind of pending to get up back on GitHub, but I just made some changes, but it'll be back up and people can access these things. So with teachers and students, one of the things we're working on is curriculum ready kits. So things like the open flexure microscope, like I mentioned, which already exists, but isn't really curriculumized, not really approachable for a teacher to use in a classroom. I mean, teachers know how to 3D print things. Schools often have 3D printers, even in rural areas. But how do you go from the process of 3D print it, I build it to figure out if my students will like it, and then I teach my students to build it, and then now we're going to use it for STEM. It's a lot of work to put on teachers, and all of it doesn't happen during work hours. So trying to build curriculum-ready kits that teachers can order, essentially at cost, would be one way to reduce those barriers. As I mentioned before, so state-aligned teaching materials. So for example, for the Alabama Department of Education, I'm trying to align some of the emerging AI and machine learning standards for the open flexure microscope. So I'm going to have the students, bought them some centrifuges to go with it, and they're going to bring soil and water samples from their households or from their communities and schools, and we're going to analyze them and see what kind of bacteria and proteins are in their environment, in their context. So this is not only is what's called place-based education. This is not only aligned with teaching standards in terms of, what does a machine learning algorithm do? Here's what a neural network is. Now let's use it on your backyard and figure out, the context you've been living in. You can kind of view it from a whole new lens. So aligning the state standards with open source technologies with place-based education. And of course, the idea of bringing tools into play. So many of the students, I've heard from the teachers that many of the students in upper grades and middle school don't know how to use a tape measure. And I mean, to be honest, it's a tough tool to use. But bringing it into a fun and engaging environment where you're building the tool, and it really matters if you get it right. I think that's a way to help them engage with these things and learn how to use tools they would have otherwise, found cumbersome or not engaging. I'll quickly go through kind of the hobbyist and makers space. So there are more advanced kits that we're also trying to package. So these would be for people who are wanting to learn, but maybe have a bigger budget or maybe have more time and energy on their hands. We're also developing Humin Labs original modules. So, for example, build your own DC motor. Coil the wires, solder the commutator together. And so one of my big goals here is when you buy a robot or a like RC car or something, it comes prepackaged with a motor. You don't get to decide the speed or the torque, which is fine for high volume, high throughput manufacturing. But when you want to build high torque robot arm, short of buying that whole apparatus, you're not able to have a bespoke custom DC motor. And another thing that motivated me with that is, a lot of the stuff that we talk about in the space is open source, but like how open source is it? Like, are the capacitors open source? Are the inductors open source? Is are the computational modules open source? So DC motors are one of those parts that are in a lot of open source technology, but it's not clear that they're themselves open source. What I'd really love to do, and obviously making your own DC motor would be, it's sometimes on the order of difficulty of making your own capacitor or resistor. Like, why would you do that? You should just buy the closed source and put it in your open source version, because that's about as open source as you can get, right? But actually, you can make DC motors. It is possible, and it's the function of your car and your generator and your, list so many different ways DC motors interact on a day-to-day basis. And so, trying to bring some of these closed source things into the open source world from a modular level to integrate with existing open source platforms. Another thing I'm working on is the co-investigator program. So this idea that instead of me or a team of people working on hardware, so bringing it into our space, taking it apart, figuring it out, is it useful for teachers, is it useful for students, can it map to STEM standards? We actually want to build up co-investigators who can either invent open source tools and then evaluate their readiness for STEM integration, or act as validators, picking out open source tools that exist and then pitching them to us and to their communities as open hardware platforms. Finally, with NGOs and universities, again, we're wanting to build on some of those collaborative research platforms, especially building pipes and pathways for middle schoolers and high schoolers in contexts where college education isn't a traditional route, and helping them to get exposure to the tools and the resources where they can actually engage with material at an undergraduate or graduate level. So, trying to make the next generation of K through 12 students, engage with academia and research, and also to help undergrads and graduate students in places where having access to these types of tools may be difficult. There may be one shared among a lab space, and you want to run your code. So run it on the open flexure microscope and see if it works, right? So scalable solutions, which are things that NGOs and universities already use as part of their research. So the haptic paddle is an example of one. I don't actually know if I've gotten that one certified yet, but I should. And in any case, it is an open source hardware platform that's existed for a number of years. It's been formally studied and published in terms of it has been shown to improve knowledge retention in physics classes and engineering classes. So it's something that I really want to hone in. It's something I also used in my dissertation for haptics and other research like that. But to bring it back into the fold of, this is a great ed tech hardware that most people don't know about. It could be in every household easily. And it could be a way to, it could be something as simple as like a joystick for a video game, but it could also be used to talk about, what does the physics on other planets feel like? Because it's a haptic device. The other thing I'm really interested in is developing transparent validation frameworks. So in addition to these hardware platforms that we're researching and kind of repackaging for EdTech, is we're developing a web platform where for many of the electronic devices, you should be able to either connect to the internet through a Wi-Fi adapter or connect to your laptop or a Raspberry Pi through USB and connect directly to our web app. And all of our materials will be hosted through the AT protocol. And so the idea is that we want to make our tools modular and easy to self-host and easy to access from anywhere, while retaining transparency and enabling people to lean on a platform that they trust. So I'm preaching to the choir, why open source, but some of the ideas of why a quote unquote business might engage with open source in terms of how do you compete as an open source business? There are many reasons. Some of them that I find particularly interesting are the principle of cost transparency. Am I running over time, by the way? Am I doing okay? Does anyone? Did I leave the call or something? I see 7 minutes.
Oh no, you're all good.
Okay, great. All right. So I'll just quickly run over some of these. So cost transparency is pretty self-explanatory. The notion that when you buy something that's closed source, you may not necessarily know what your money is going towards. Is it going towards? Does the material really cost this much? Did the engineers really get paid, so much that the device should cost this? And it's hard to tell, especially when obscurity of the design, intentionally obscured, makes it difficult to gauge what should the price of this thing actually be. The idea with open source is that you can determine at any given time what the price of an object should be based on the cost of the components at that given time. Now, the maker of the device is certainly free to add a cost for their time and their maintenance and their services, which is kind of part of the model of Humin Labs. But at least it's transparent. People really know what they're paying for. They feel a sense of trust when they're buying something like that. And you got to build on that. So the documentation is a big driver for open sources. Not only that it's well documented, but that it can be maintained by a community of people who aren't in constant contact with each other, and so in a quote unquote democratic way. So the idea being, you give a university or a high school campus, 100 open flexion microscopes. Will they be obsolete in a year? That's a question to be asked, right? And the answer is most likely not, because a lot of people who aren't in this space are using it and maintaining it and uploading, and you can simply download those upgrades. So you're not waiting on a small community of engineers to upgrade their products. So the core values of open source, it is true that for something to be open source, simply the source should be open. At the same time, there are a lot of, in the hardware space, open source ethos that goes on. So things should be modular. They should be low, in cost and high in functionality, the so-called appropriate technologies. And so kind of embracing some of these core values of open source is a way to engage with folks who are maybe have challenges with traditional supply chain. So for example, products by Lego, I don't mean to name call people. Lego robotics is great. People should buy it. I used it. It's a great product. But if their engineers are designing it in such a way that it's useful for their existing manufacturing pipeline, not for, increasing the accessibility for anyone to make and use them, then there's a bind there. And that may align well with Lego's values, which is to produce the highest quality product that they're capable of producing. But it's at odds with open source values, which is maybe not to produce the highest quality, but to produce the most accessible thing. And so kind of that there's some play there, but it's one of those ideas that open source kind of is drawing the community back to evaluate appropriate technologies. So how do we plan to make a profit? Because we're certainly not doing that now. Of course, my website is now broken, but what I would say up here is we have no IP. And so we're not inventing anything. People have already invented things, and we are slightly tweaking them to make them manufacturable and easy. Our web app would be one of those big costs that we have actually hosting something like that on a web server and maintaining tools like storage and messaging, maintenance and support for a web server to host a pretty significant platform that might be, you could connect an open flexion microscope to it. You could connect, any kind of open source tool to it, and it should provide you with options, curriculum, a forum, and other things like that. So that would be an expensive thing to host. Obviously, if we're going to be distributing some of these open source things to folks who may not have 3D printers, manufacturing, assembling, logistics, and then finally developing a community out of this where folks actually, especially teachers and K through 12 administrators who may not have the time to engage with something like this, kind of building those bridges. The revenue, obviously, if we're hosting digital services that include functionality like storage, messaging, integrated grading for teachers who will do something like that, that is going to come at a premium that, again, it's self-hosted, so you could do that. You could make your own thing. and people should do that. But to get the official maintained version, there'll be a premium on that. And then if we're manufacturing, assembling things, there's going to be some B2B or B2C ideas where we are simply trying to recoup our costs on manufacturing logistics. My real hope is that this eventually becomes something that city level governments, state level governments, and hopefully federal level governments will view as worth their time, money, and effort to engage with. And so that's kind of the plan, is to link existing open source hardware with needs in ed tech, try to massage out some of those alignment issues in partnership with teachers. So I've got some teachers that I'm working with who are helping me write the curriculum. I'm just not coming out of my head. And I've also got folks contributing project ideas that already exist and that we're trying to develop. So there's a lot going on there. And I think that's just about it. That's what I wanted to present today was a model and kind of see how the community is thinking about this topic. But do y'all have any questions? Yeah, I'm ready to wrap up.
That is really rad, and it's so great to hear so much about what you're up to. We do have a friend saying that it's a great cause, and I agree.
Open source and education are so closely related, so it's really, really great to see you working in this space and everything that you're working towards. So thank you.
Thank you, y'all.
Thanks, Avinash. We'll